So our next speaker is Mr. Jayamini Ranaweera. He's a chartered engineer and is currently working as a data scientist with Bath Rugby UK, while also reading for his PhD with Leeds Beckett University in UK. Previously, he was a manager in research and innovation at MAS Intimates. He has obtained his bachelor's degree in applied sciences from the University of Sri Jayawardhanapura, Sri Lanka, and his bachelor's in engineering from Sheffield Hallam University, UK. He has completed his Master of Science in Electronics and Automation from the University of Multidisciplinary, Sri Lanka, while also engaging in multiple research endeavors in biomechanics, sports technology, industrial automation, and digitization. Today, he is going to be talking about innovative technology needs for Sri Lankan sports. Over to you, Mr. Ranaweera.
Okay, so today my topic is going to be around innovative technology needs for Sri Lankan sports. We listened to a lot of insights from a more clinical and more lab-based kind of approach, but I'm going to talk to you from a more applied perspective because I work in an applied setting in Bath Rugby, working with some of the top rugby union players around the world. Therefore, I'll be talking to you from a more applied perspective. So today's discussion is going to be around three key sections. First one being technology applications in real-time player management, how it's done in an applied setting. Second being how we can bring that into a Sri Lankan context. Section 3 would be around some design concepts and around affordability and how we manage quality when we are designing these systems. But I'll only go to that section if there's time now because of these technological labs. All right, so the first section is to understand initially what athlete management is. So essentially, athlete management is managing an athlete's physical, physiological, psychological, technical, and tactical preparation and performance. So that is a clear enough definition. So let's bring the topic forward with looking at a more physical and physiological perspective. So conventionally, this is how you would normally manage a player, probably in the pre-technology era, where you would have an athlete, you would go through a training session and he would subjectively measure something like his training load if you're looking at it from a more physical, physiological perspective, and then give feedback to the coach, whereby he would adjust his session plan. Now, a feedback loop like this had two key problems. One being we didn't have kind of proper objective measurements to measure this training load, as well as we didn't have proper digitization technologies to give this feedback to the coach to make more objective decisions regarding player management. But due to two main reasons, I think we've talked about this a lot now, due to miniaturization of electromechanical systems, as well as a significant increase in computational power, these player management models have changed to something like this now, where there is more objectivity around actually measuring or managing the player, where we have better objective measures to collect the data relating to the player, as well as to give this feedback and to the coach in more objective manner. I'll talk to you about this in the next few slides, but this is how it's kind of transformed now, which is more detailed at the present situation. So let's look at how this transformation has occurred. So the first one being, if you look at on this top right, is to, like I said before, transforming from more subjective measures to more objective. So this is mainly done in applied settings based on wearable sensors. These are some, we've discussed a lot about this, so I won't repeat, but some of the things we haven't touched base are some things like velocity-based training, where, for example, if you want to have like a dynamic, if you're going through like a dynamic strength training session and you want to see how fast you're lifting, you'll probably put a band like this in and then see how fast your hand is moving, for example. So with these kind of wearable systems, even things like surface EMG have been there for a little while now. So these sensors now give us a more objective measure in terms of measuring the training load. So the next part is actually how do you give this feedback properly? So that is essentially done through things like data workflow models. I won't go into a lot of detail because it's a lot technical around this, but in generally how it happens is that you have like transformation methods like ETL or ELT, where you have different sources to get this data from the player, variables being one. So it will be either an API or a database or different files. So you extract them and then you transform it into a way that you want to look at it. Why this is unique to specific club is because every club has different objectives as to how they want to manage a player. Their goals are different. So therefore, you have to transform this data in a way that is applicable to you. So then what you do is you transform it and then you load it into a data warehouse or a place where you manage this data in a way that you want to look at. And then you transform it into analytics and you give back coach feedback to the coach, whereby he can do the adjustments. So that is the theoretical construct of how you kind of manage a player with variables and data analytics. But now let's look at a more applicable example. So let's take one from rugby union, where with motion capturing, as you would have heard from previous speakers, we have wearable sensors. This is mainly like a GPS and IMU combined together, where each player would be wearing it during training as well as competition. Therefore, with this motion capturing, now we are able to classify different events during rugby, for example. So we can classify things like the kicks, the scrums, or the contact involvements. So, so that is based on motion capturing as well as using things like machine learning models. So now let's look at one specific parameter in slightly more detail to understand this better. Let's look at the contact involvement parameter. So if I just play this video, if you can see this player, Sam Underhill, is tackling Damian McKenzie here. So that's a full contact involvement there. So it will play again. So he runs in, goes into the collision, and then he gets back up. So this sequence of events is of importance to us. Why? Because it will define how this player is his work rate is. Because let's say, for example, people who know rugby will understand, like, you need to be back into your defensive structure, or you have to go back into your attacking shape quickly. So that will define as to how long he spends in his contact. So if he's spending more time in a contact, then he'll be taking more time to go back into his shape. So to do that, we want to look at this duration parameter of this contact. In terms of motion capturing with the wearable sensor, how it happens is that in 4 key stages. So initially the player would be upright, and then he would go into a collision. And then he would go into his post contact, and then he'd be back on his feet. So at this instance where he goes from his initial orientation to a change in his upper body and to contact, triggers initial event, and then when he's coming back on his feet, it completes the event. So this duration is important to us, like I said before. So now with the metric in mind, now let's look at how that is used for an actual analysis. So one of the questions then we would ask is, for example, if we take the same positional group, let's say we are looking at all the props, for example, that's a positional group in rugby union, and we want to know how across this group, how players are spending time in this contact involvement. So this is again not a big machine learning model, but just a simple analytics. Sometimes these are more powerful. So what we would do is, for example, we can compare 4 players in the same positional group and look at how they are spending time in the contact involvement. So in this box plot, you can see each dot represents a contact for each game here. And for example, if you look at player A, he's spending about 4.8 seconds per contact on average. This is a median in this game, where when he's going through about 56 contacts in the whole game. And you can also see with the box plot that the width of the box is also low, meaning consistently he's maintaining this, as well as it is consistent throughout the games as well. But in comparison to a player like player B, for example, his contact involvement duration on average is slightly higher, and the box width is higher as well. So when we look at now, when we give this feedback to the coach, what we do understand, let's say looking at player B, would be that he has an issue with his tackle technique. So if I go back, what happened is that player, he would more so often, after his post contact, would go get underneath this tackle player, or in most cases there'll be more players involved in the tackle. Thereby he would take him more time to get up and come back to his defensive shape. So that's like a full cycle of a practical example in an actual applied setting, how from variable based motion capturing to actual data analytics, and how it goes back into the coach for feedback as well. Right. So, and this is another example where I think this might be interesting for people who are trying to analyze movements as well, or rather data analytics in two-dimensional space, for example. So this is some analysis that we do. We look at the spatio-temporal aspects. Unlike in football, for example, where these data are generated by optical systems, in rugby, we don't have a lot of money. So therefore we have to innovate. So we had to find, rely on the GPS to go for these two-dimensional kind of analysis. But one thing I want to highlight here is that, for example, if you want to synchronize a GPS as well as a video feed, you can go with a parameter like a kick. So because our classification accuracy, we can classify with one single motion IMU sensor very accurately, then you can use that specific parameter to synchronize the video as well as the GPS. If you look closely, these two data sources are properly aligned. It looks the same way. Okay, so that brings us to our second section, which is how we then bring these kind of applications where it's used in really high-end applicable kind of areas in sport right now. How do we bring it to our benefit in Sri Lankan context? I think to answer that, first, I think this question needs to be answered. That is, at what sports do we have the capacity to reach world-class levels? So this is a big research question. Unfortunately, I have no answer. Why I put it out here is that so that it can motivate the audience here would be from sport enthusiastic backgrounds to do research to see actually what games you can be, reach world-class level. And what I mean by is like being top 5 or top 10. Why? Because if we apply science and technology to those sports, then we'll have a great chance of achieving better successes. So traditionally, I'll bring this argument a bit further, is that I want to argue that saying success of a game would rely on two factors, two main areas, one being the skills as well as other factors like anthropometry. Why I say that is, for example, if you take like a game of volleyball, sometimes although you have the definite skill sets, if you don't have the anthropometry, you might not be able to reach world-class levels. And that's a realistic fact. It's there in rugby as well. But whereas, like, let's say a game like table tennis, where it's more skill-driven, it might suit, let's say, our context as Sri Lankans to go into this world-class level. Now, this is a question that I leave to you, the audience, to explore in great detail. I'll be happy to get involved as well in such a research. But let's bring a hypothesis here. I'm going to be brave and make a hypothesis and say that for Sri Lankans, it's going to be more skill-based sport that is going to be, that's going to take us to the world-class level rather than which would rely on more anthropometry, like let's say, for example, rugby. So that leads us through like some sports, let's say racket games as well as cricket. We've proven we can argue cricket is generally was a skill-based game. Now it's kind of moving into a power game, but still we've shown success, as well as athletics. But what these have all in common is that they have repetitive movements whereby motion capturing can become very beneficial. So in that line of thinking, I tried to tackle this question in my previous research about 4 or 5 years ago. I tried to bring in like wearable sensors to classify fast bowling activity phases, similar to what Mr. Udana was talking, but from a wearable sensing and machine learning perspective. So the question was that if I use a wearable sensor, so if I have a sensor on the forearm, it will look something like this. But from that alone, if I want to just look at the run-up or the delivery slide independently, I wouldn't be able to do that because it's a discrete, or I wouldn't say it's a continuous, but discrete data stream where you can't segregate. So that was a question that I wanted to tackle. So this was a hardware which was done initially with the first starting of Kairos sensing team. Guys, this is a small software setup to collect that data, some software programming, tested with some fast bowlers and build a supervised machine learning model. I won't go into details. But it was features were collected based on a moving window with 400 like samples window with 50% overlap. And then I use feature selection and dimension reduction techniques and then use a classifier. So these are some of the findings from that where I've used something like a KNN here and then to classify the 3 phases. And then use a test classification to see how accurate this will perform. And as you can see, it was only about 80%. But the main reason being the initial training model, the training data sets were done with reference to like a normal video camera because we had no access to a high-end motion capturing system. Therefore, the initial data, the training sets weren't too great. So, but this was just an initial attempt to go through this. To tackle this problem, like opportunities from a Sri Lankan context. Unfortunately, I think my time is up. I think So I don't think there'll be enough time to go into section 3, I assume. So yeah, thank you.